Hello and welcome to my channel Econ Academy. In this tutorial I will explain what is multicollinearity, how to detect it using rule of Lawrence-Klein, and how to treat it. So do like the video and subscribe to my channel. So first of all, what is multicollinearity? If one independent variable is a linear combination of another, we say that there is multicollinearity between them. But now question arises, what level of multicollinearity exists in our model? If there exists a low level, then we will say that it is not a problem, and if there exists a high level of multicollinearity, then we will say that there is a problem of multicollinearity in the data. One more thing, multicollinearity is a problem of data, not of model or estimation. So we can even check the multicollinearity before the estimation of our model. So the coefficient of OLS will still be blue even in the presence of high multicollinearity. The coefficient will be correct even in the presence of high multicollinearity, and R square might be false in case of multicollinearity because it will be very high, and in actual the R square will not be that high, but because of the problem of multicollinearity, the R square will be very high, and the standard error will also be very high of the variable in which there is multicollinearity. So this is something about multicollinearity. Now I will show you how to detect multicollinearity using rule of Lawrence-Klein. So the rule of according to this rule, first of all we will run our original model. So in this data I have already imported time series data and already instructs data that the data which I have imported is a time series data. So one thing more, this problem may be exist in time series or even in cross-sectional or even in panel data. So whatever the data is, this problem can exist. So now first of all, according to rule of Lawrence-Klein, we will run our original model. So for running a regression, we have a command reg, and then we will write the dependent variable, which in this case is growth, and then the independent variables, which is government spending, GS, and government spending volatility, GSV, and investment, and what is the other variable, which is investment volatility, and openness. Now this is the model, our actual model. This is the regression command reg, and growth is the dependent variable while all the other are independent variables. So now we will press enter. Now according to Lawrence-Klein, we will note the R square of that model. The R square is 84.03 in this case. 84%, R square of this actual model is 84%. So first of all we have to note that in the according to rule of Lawrence-Klein. Now we will run an auxiliary model of the variable on which we have doubt about multicollinearity. So we will keep one variable as a dependent variable and all other as an independent variable of that on which we have doubt of multicollinearity. Now suppose I have doubt about that this government spending and government spending volatility and investment have multicollinearity between them. So now we will run another auxiliary regression, and we will keep one of them as a dependent variable, and others 2 or 3 or whatever number in whatever number they are, we will keep them as independent variable. So now we run the regression again with keeping one of them as a dependent variable. Let's suppose we'll keep government spending as a dependent variable, and we'll keep the others as an independent variable. So uh, we will run, run the command reg. We will run the command reg gs and gsv and I. As I have already told you that it is an auxiliary regression, and in this regression we will keep one variable as a dependent and other as independent variable. So I have keep Gordon standing as dependent variable and all the other are as an independent variable. Now we'll press enter. Now we will note the R square of this one as well. The R square of this auxiliary regression is 22%, while the R square of the actual model is 84%. So now uh, according to rule of Lawrence-Klein, if the R square of this auxiliary regression is greater than the actual regression, that is that now then there will be problem of multicollinearity, otherwise there will be no problem of multicollinearity. So in this case the R square of auxiliary regression is 22%, while the R square of the actual model is 84%. So according to rule of Lawrence-Klein, there is no problem of multicollinearity. Now let's suppose there is a problem of multicollinearity, then how will we treat it? So according to some books, we will we will drop the variable which have one of the variable which have a high correlation between them, but it is not a good method because you might miss an important variable and your model will be omitted variable bias. So for this we have another method, and we will according to that method we will make a principal component of the variable which have high correlation, which have multicollinearity, and we will run the regression based on that. So this method is called principal component analysis. As we have supposed that um, there is multicollinearity between this government spending volatility and investment, so we'll make a principal component of these three variables, and we will run it as an independent variable in our original regression. So for the command for principal component analysis is pca, and then the name of these variables, that is government spending volatility and investment. So the command is pca, and then the name of these three variables, which is government spending gs, and government spending volatility, that is gsv, and investment, that is I, and we will press enter. Now we will give a rotate command in the command section. So the command is rotate, rotate, and we'll press enter again. Now we will predict a new series of that which will be principal component of these three variables. So for predicting the new series, for predicting a principal component of these three variables, we will write predict, predict, and then the name of the new variable which will be the principal component of these three variables. So we can give any name. Let's suppose give it as g. Let's suppose give it as iv, ivp, and we'll press enter. So this is the new variable which we have created, and it contains the principal components of this government spending volatility, and this investment. We can also browse that by command br and the name of that variable ivp, and press enter. So it contains the principal components of government spending volatility, and investment. So now we can also run we will run regression based on this principal component. So instead of this government spending, volatility and investment, we will write this series, this principal component analysis, this principal component series. So we will write reg, and growth was our dependent variable, and the name of this principal component ivp, and what other variable which we have run in that model, that is iv, investment volatility and openness, and we'll press enter. So now this will be the final model, and which incorporate the principal components of government spending, volatility and investment, and there will be no multicollinearity in this model. So this is from today's tutorial. Do like the video and subscribe to my channel. Bye for now.